In this lesson, we're going to be reviewing scale models. Remember, a scale drawing or a scale model is used to represent an object that is either too big or too small to be shown in actual size. The dimensions of an object on the scale drawing or model are proportional to the dimensions of the actual object. Remember, the scale is the ratio of the size of the model to its actual size. So, model to actual. The scale equals the model compared to the actual. And remember, we can write a ratio with a colon like I just have, with the word to like it did in the statement above, or with a fraction bar. And that's the way we've been using it mostly, with the fraction bar. A scale can have the same units or different units. You can use a scale to find a missing measure on a model or the actual object. These are the two things we're going to be looking at today. You simply have to set up the proportion and solve it. So let's dive into some examples. Eric is planning to build a raised garden. He sketches a plan with a scale of 1.5 inches to 4 feet. If the garden has a width of 4 inches on a drawing, what is the actual width of the garden? So remember, when we set up the proportion, the first ratio in our proportion is our scale. So 1.5 inches to 4 feet. The second part of our proportion is the other piece of information the problem gives us, and that is that the width of the garden is 4 inches. So we're going to write a ratio of 4 inches to X number of feet, because that's what we're trying to solve. We're trying to find out how many feet. Once the proportion is set up, we simply cross multiply and then divide. When we cross multiply 4 times 4, we get 16. Then 16 divided by 1.5. You can go ahead and use a calculator to divide 16 divided by 1.5. When you do this, you see you get 10.6 repeated. So 10.6 repeated feet would be the width of the garden in actual real life. Alicia wants to enlarge a photograph to make it into a poster for her room. The photograph is 6 inches tall. The poster will be created using a scale of 4.5 inches to 2 inches. How tall will the poster be? So again, we want to set up a proportion with the left side or the left ratio as our scale, 4.5 inches to 2 inches. The other side of our ratio includes the information we're given. We're given that the photograph is 6 inches tall. So we have X inches to 6 inches. So remember, when we write our ratios, we're writing them comparing our model to our actual. And we want to keep that consistent within our ratios. So that's why we have the 6 inches here on the bottom instead of the top. Once this is set up, we simply cross multiply 6 times 4.5 divided by 2. And again, go ahead and use a calculator. 4.5 times 6 equals 27. And then 27 divided by 2 equals 13.5 inches. And you always want to think about, does this answer make sense? Well, if you think about the problem, she started out with a photograph and she went to a poster, so she's getting bigger, a picture to a poster. And my answer did get bigger. We went from 6 inches to 13.5 inches, so my answer does make sense. Number 3. James is building a dollhouse that is proportional to his own house. He is using a scale of 1/2 inch equals 1 foot. If the dollhouse is 12.3 inches tall, how tall is his house? So we're going to use our scale and the information written to write a ratio or to set up a proportion. So the first ratio is our scale, 1/2 inch to 1 foot. And then the second part of our ratio is the information given. And we're given that the dollhouse is 12.3 inches tall. So that's 12.3 over x. So once this is set up, again, we're going to cross multiply 12.3 times 1 divided by 1/2. So go ahead and use a calculator. 12.3 times 1 is 12.3. And then 12.3 divided by 1/2 is 24.6 feet. Number 4. A drawing has been enlarged using a scale of 1 inch equals 1.5 inches. If the original drawing was 4.6 inches long, how long is the enlargement? So again, setting up a proportion where the first ratio is our scale, 1 inch to 1.5 inches. And the second ratio is the information given. The information given is that the drawing is 4.6 inches long. So 4.6 over x. Once we have it set up correctly, it's simply a matter of cross multiplying and divide. So cross multiply 4.6 times 1.5, and go ahead and use a calculator to do that. And we get 6.9. Then 6.9 divided by 1 is 6.9. And again, thinking about, does my answer make sense? The original drawing was 4.6 inches, and it got enlarged, which means it gets bigger. So 4.6 to 6.9 would make sense. Let's take a look at number 5. The Mount Rushmore Monument is 60 feet tall. A model of the monument is sold in a gift shop. If the model was made using a scale of 1 inch to 40 inches, how tall is the model? So we're going to use that scale and the 6 feet to set up our proportion. 1 inch to 40 inches equals x over 720. So you might be curious, where did I get that 720 from? Well, if you notice, the problem uses 60 feet, and we want that feet to be in inches. So we know there are 12 inches in a foot. So if we multiply 60 times 12, we get 720. Once this is set up, we can cross multiply 1 times 720 and then divide by 40. So go ahead using your calculator. 720 times 1 is 720. And then 720 divided by 40 is 18 inches. Number 6, an architect is reviewing plans for a house. A living room measures 4 inches by 6.5 inches. If the plan if the scale is 1 inch to 3 feet, what is the area of the actual living room? So this problem is a little bit more in depth. Remember, in order to find that area, we have to multiply our length times our width. And it wants the actual area. So we have to find our actual length and our actual width. The problem tells us our length and width from the drawing is 4 inches and 6.5 inches. We can't use these numbers to find the area. So we can use these numbers in the scale to find our actual dimensions and then find the area. So first, let's focus on the length of 4 inches. And let's find that actual length. So using this scale, 1 inch to 3 feet, and the fact that it's 4 inches over x. Cross multiply and divide. 4 times 3 is 12. 12 divided by 1 tells us that our actual length is 12 feet. So we're going to use this in a minute to help us find our area. Next, let's find our width. So the width in the drawing is 5 inches. So using that same scale, 1 inch to 3 feet, and then we know it's 5 inches on the drawing, and we're trying to find how much in actual life. So then again, once it's set up properly, we can cross multiply and divide. So 5 times 3 is 15. 15 divided by 1 is 15 feet. So the width is actually 15 feet. So now that I have my two actual dimensions, I can now find the area. And remember, to find area, we multiply our length times our width. So we're going to multiply 12 times 15. And you can go ahead and use a calculator to multiply that. Oh, I just realized I used the wrong number here. This should be a 6.5. So let's replace that with 6.5 here for our width. Sorry about that. So then that's going to change the actual. So we're going to cross multiply 6.5 times 3. And you can use a calculator for that. And that gives us 19.5. And 19.5 divided by 1 gives us 19.5. So our actual width equals 19.5. So that's what we're going to use to find the area. So we will plug that into our width. So 12 times 19.5. And again, putting that into a calculator, we get that the area is 234. Number 7. A large map has a scale of 1.5 inches to 40 miles. If two cities are 1.5 feet apart on the map, what is the actual distance between them? So again, we're still going to set up our proportion using our first ratio as this scale. And instead of writing that as a fraction, I'm going to write it as a decimal. So 1.5 feet to 40 miles. And then we know the distance on the map between them is 1.5 feet. And we want to know, well, what is that actually in real life? Well, before we can do that, so remember our scale says 1.5 inches to 40 feet. And this tells us on the map it's 1.5 feet. So we want to change that 1.5 feet to inches. So 1.5 feet to inches. And again, we know that there are 12 inches in a foot. So the whole, that 1, that's 12, plus a half of a foot is 6 inches. So 1.5 feet is a total of 18 inches. So we're going to be using 18 inches in our ratio. Because remember, we want everything to line up by our units. So since I'm using inches here, I need to use it all the way across. So now that we have it set up, we're going to cross multiply and then divide. So we're going to cross multiply 40 times 18, and you can put that in a calculator. That gives you 720, and then 720 divided by 1.5, again, placing that in the calculator, and that gives you 480. Number 8, students in Mr. Morgan's math class were asked to produce a drawing of themselves using a scale of 0.75 inches equals 2 feet. Travis is 5 feet 8 inches tall. How tall will his drawing be? So again, we're going to use the scale to set up our first part of our proportion, 0.75 inches to 2 feet. And remember, when we're setting this up, this is model over actual. So in actual life, he is 5 feet 8 inches tall. So that is going to go down here in the bottom. And we don't know what it is on the drawing, so that's going to be X. Now, I can't put 5 feet 8 inches in our proportion. So we have to convert 5 feet 8 inches to the feet, because that's what we're using, to feet. So to convert that, it's going to be 68 inches, so that we're talking about the same thing, inches and feet, because we're talking about inches and feet. So we're going to replace that with 68 inches. So then we're going to replace this feet, 2 feet is 24 inches. So that we're talking about the same thing going across. Because it's a lot easier to change it into all inches instead of trying to change this to a portion. It would be 5 8/12. So we don't have to deal with that fraction. We just change it all to inches. So then once it's set up, we can cross multiply and divide. So 68 times 0.75, and you can place that in a calculator. And you get 51. And then 51 divided by 24 gives you 2.125. Now the next part we're going to be looking at is finding the scale. So in the previous problems, your scale was given to you and you had to find a missing piece of information. In this next set of problems, we're going to find the scale. So there's a couple steps that you do when finding the scale. First, you want to write a ratio. So remember, we write that as a fraction of the model to the actual. Because remember, our scale compares the model to the actual. Then you're going to simplify that ratio so that the numerator is 1. So let's take a look at what that would look like. Number 9, the model is 6 inches. The actual is 72 feet. So remember, we're writing a ratio, your model compared to your actual. So our model is 6, our actual is 72. So that's step 1. We wrote our ratio comparing those two. Step 2 is we want to simplify that down so that this numerator is 1. So to simplify that down, I know that 6 is going to divide evenly into both that numerator and denominator. So 6 divided by 6 is 1, and 72 divided by 6 is 12. Now that my numerator is 1, and it might take a couple of times simplifying it, but you want to keep going until you get that numerator of 1. Once that numerator is 1, you have your scale. So our scale is 1 inch to 12 feet. And I was using those dimensions from our original problem up here. So the next one, number 10, the map distance is 36 centimeters and the actual is 4.5 kilometers. So again, our ratio is always our model to our actual. And our model is 36 centimeters to our actual 4.5 kilometers. So I'm going to simplify this down. And this one isn't quite as easy to simplify down because you have that decimal or that fraction in the bottom. But it can simplify all the way down to 1 over 0.125, which would give us a scale of 1 centimeter to 0.125 kilometers. Number 11. A poster was made of a 6-foot-tall musician. If the musician on the poster is 20 inches tall, what was the scale used to make the poster? So this puts it more in context of a word problem. So we're still using model over actual, but you're just going to have to be able to read and interpret what's your model and what is your actual. The model is 20 inches and the actual is 6 feet. Because that's what would make sense. It's a person, it's a musician. And a person wouldn't be 20 inches tall. The person in actual real life would be 6 feet tall. And then we're going to simplify this all the way down. And this is another one that doesn't simplify down as nicely as number 9 did. But when we simplify it all the way down, it comes out to 1 over 0.3. Which as a scale, because remember we want that that numerator is 1. So as a scale, that's 1 inch to 3/10 of a foot. So you want to change that decimal to your final answer as a fraction. And if you leave it as a decimal, it's also fine. Just know it can be written either way. Number 12, a model airplane is 18 centimeters long. If the actual airplane is 60 meters long, what scale was used to create the model? So again, model over actual. And this one actually uses the word model airplane is 18 centimeters. And then actual airplane is 60 meters. And then we can simplify that all the way down to 1 over 3.3 repeated, which as a scale would be 1 centimeter to 3 1/3 meters. And then remember, you can still use a calculator on these bottom ones to help you simplify them down. You just want to make sure you're simplifying them all the way down so that your denominator is, or your numerator, your top number, your numerator is 1. So if you simplify it and that numerator is not 1, Just keep simplifying it down until you get a numerator of 1.